Start recording. Okay, hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. I am pretty excited about what's about to happen here. I don't know, I guess I don't know, we might hit some snags, but yesterday we were just about finished moving everything over to the new logging system, and we were sort of putting stuff in so that even the old platform layer stuff that used to kind of go through a different way of logging timestamps could go through our new debug logging system. And I'm kind of excited about that because once that's all working, we'll be able to make some pretty cool visualizations of like where the time is being spent in our program, and that's something that I'm relatively interested in seeing myself. So I'd like to get into it right away because we were right in the middle of it yesterday, and so I'd like to go ahead and get it finished here. Today is day 183, so if you want to follow along at home, unpack day 182's source code into a directory, and that is what we will be starting with today. So here we go. If you remember correctly, we had finished getting everything working, and it actually was running just fine with the new system. However, we had not yet actually taken advantage of the porting work that we had done. So actually, if you look here, we're not actually putting anything from the platform layer in this actual system yet. We only have stuff that's from the game itself. And so what I'd like to do today is push that through so that we can get to the situation where we've got everything, including the platform layer part, showing up. So let's go ahead and do that. If we go into Win32 Handmade, right, what we need to do here is we moved the stuff into Handmade platform. If you remember, we sort of put it down at the bottom here so that it could be accessed by both systems. So we can actually start using it here. We can start using like timed block and that sort of stuff in here. So what I'm going to do is I'm going to just go ahead and vaporize this, excuse me. I'm going to vaporize this debug frame and info concept, this thing where we have like debug frame timestamp and that sort of stuff. I'm going to get rid of that, right? So that's going to go away. And instead, what I'm going to pass in place of that particular set of information is I'm going to pass in the sort of array of counters for the platform layer translation unit. So what it's going to pass here is it's going to pass essentially, in this handmade debug thing here. When we get down to the bottom, right, we've got these sort of debug records that we, I'm sorry, that's not the one I'm looking for. We've got these debug records here where we say, like, okay, we've got the debug records, main count, optimize count, platform count, right? And then each one of those has a record array which stores stuff like the file name and that sort of stuff, right? So we have this global debug table.records thing. That's the thing that I actually want sort of to be recorded there, right? And I guess, thinking about it a little bit further, I guess I could, since the platform layer would actually have the ability to access that debug table, it would seem, because, it's actually, I think it should be able to access it because we can sort of load the address of it there. We can get that piece of information out of the platform independent code. I feel like we might not even have to do anything specific because we wouldn't have to pass the records themselves. We can just write directly into them. So yeah, that actually seems like it should be probably pretty easy. So maybe I can just vaporize that thing entirely, I guess. It seems like I could. I don't know. So I'm going to go ahead and try that. So if I was going to do that, how would I do that? If I want to vaporize that thing entirely, I can just say the debug frame end info is just going to go away, like there it goes, and then we get rid of this, and that's all there is to that, right? And then I would come in here and say, all right, we don't have any of that anymore. That's gone. We don't have any of this stuff anymore. Now, I'm not going to delete it because we're going to want to convert that over because we want to use those bar charts again. So at the moment, I'll just if zero it out. It's going to come back later, and it's just not going to be drawing the frame infos anymore. It's going to be drawing something else. But otherwise, it'll still be pretty similar. So once we get into here, when we do Win32 record timestamp, that is no longer going to be a thing. We don't need to do that anymore. We can just use the timed blocks. So what I'm going to do there is I'm going to say that we just have a time block here, and that time block is going to be our global running block, this block right like there. And we're going to want a way, I think, to start naming these things. We're going to want a different version of time block that would allow us to name things more specifically for when we have these here. But I'm not going to worry about that at the moment because we don't care about that too much here. But what I want to do now is I want to be able to do sort of the traditional begin end block pair, if that makes sense. I want to be able to do that a little more manually so that I can do like little snippets here, like little bits of this. So if I take a look at Handmade platform, right, a timed block is really just, you know, it's one of these and one of these, right? It's a debug, it's an end block event and a begin block event, and a thing that like accesses the records, right? That's all that is. So what I want to do here is just extend this up sort of one more level, so that what's actually happening in here, right, is kind of going to be, well, I'm trying to think of maybe even an easier way to do it would be just to have the exact same thing, but yeah, maybe have the exact same thing, but instead of the time block automatically doing it on close, the time block just does it sort of at a different time. So I'm gonna say we've got another thing here, which is like, you know, a manual block or something like this, right? I don't know, a manual time block, and what that's going to do is that one will just do it. It needs to remember the counter, right? That's the only reason I actually need an interceding thing here. And what that'll do is when you actually create this manual time block, you will essentially do this operation. So we'll have something like this, pound define begin block, right? And then an end block, like so. Let me take a look here and make sure. I know we had some stuff in, I think the intrinsics, was it? I just want to make sure we got rid of those old begin block, end block ones. I'm pretty sure we did, right? There, this stuff. So we don't want any of this anymore, right? This stuff is all gone, basically. Goodbye. Okay? And debug global memory. I don't remember what we were doing with that. Debug global memory. Was there anything in particular we were storing in there? Like, what was that even being used for? I don't know what we were doing with that. Debug global memory, debug global memory, debug global memory, but it never is actually getting used, which is a little bit weird. Wasn't it supposed to be, let's see, debug global memory? It's weird, it never actually gets used. I guess we were planning to use that and just never did, or something. We'll have to do, Casey, actually start using this. All right. So that's a little weird. Not sure what's going on there. We'll take a look at that. Anyway, point being, so if I've got one of these guys here with the time block situation, and I guess I can kind of make these two things work in terms of each other. So when you do a begin block, end block pair, what that's going to do is it's literally just going to do exactly this thing, exactly what you see here, right? So what I'd probably do is I'd say, all right, whatever this set of events is going to be, like that. I'd probably say something like, okay, you know, I want to be able to do something of the form manual time block equals begin block or something like that. Or something where I give it a name, I guess, when I do begin block. I'm just trying to figure out like how I make sure that this counter variable can be stored somewhere so that it will get used again by the end block. Automatically, of course, I mean. And I'm not sure. I'm not sure how I would do that. So let me just show you what I'm trying to do. What I want to be able to do is in here, I want to not have to do this, right? And the reason that I want to not have to do that is because when I define variables and stuff, I don't want those variables to be scoped inside this block. I want them to be accessed outside. So I want to be able to do something like this, right? I want to be able to do something where I do begin block, and then I do end block, like so. And I can just do, okay, this is the executables ready section, and I can, just make that be like a known block, a sort of a known section of this set of operations, right? And then I can go, another step further, right, and say, okay, here's the input process. So that's another end block. Right? And so up here, when we do this, I would say begin block. And get that. And so, you can see it's pretty straightforward what I'm talking about. There's really nothing particularly fancy there. So we come through here, we do whatever the input processing is, and that's fine. Then we would come in here and do the game updated part of things. So here's another block. Right? And then we've got whatever this section is. Looks like the audio update. Yep. And block. And that's what I want. And I'm trying to figure out what's the easiest way to actually make that happen in some kind of non like annoying for the programmer, which is in this case me, non-annoying way. I want it to be able to be written roughly like this without a lot of interceding other nonsense, right? And furthermore, I would like it to be able to compile out, so I don't want there to be a lot of funny business going on, in terms of stuff that has to be named outside of the macros themselves. I want the macros to pretty much be all of it. So let's see here. Debug frame end gets called there. So then I'll just say, I guess I'll just say right about here, we'll do the end block, and that'll be the last block. Okay. Yeah. Okay. This will be, I guess, frame display. Something like that. So that's what I want. And then this can live outside it because it's still going to be included in the overall time block for this loop, right? For the whole loop. But that's about it. So I don't really know. I don't really know the best way to get it, is I guess what I would say. I guess, so here's what I'm thinking. Since those manual blocks probably want to be named anyway, what I'm thinking is maybe I don't do them quite like that. Maybe I do them like this. Something like that. I don't really like the fact that I have to copy the name in two places, but if you had blocks that were sort of enclosing each other, I feel like you would have to do that anyway. So that's perhaps not such a big problem. But let's see here. So we've got audio updated and audio updated, frame weight complete, and let's see here. So this is not really frame rate complete, it's frame weight, right? These are kind of named differently now that they're blocks. So this is the frame display, and audio update is probably without a D, would make a little more sense now, I think. Game update, audio update, input processing, like so, and executable refresh. So yeah, let's say we did something like that. In that case, we would have like a thing that comes in here that's name. And so what I was thinking we could do is we could just go like, whatever that name is. We could use as the timer. And I'll just do another thing here that's like begin block. Like so. What I'm thinking is, essentially we do the exact same thing here. So this guy does like begin block, and it just passes counter as the name of the counter variable, right? And maybe we stick an underscore at the end of that there just to make sure that it's not going to be used by anyone or something like this. Although I guess we don't have to care about that here. Yeah, although that may be something that you'd want to do. I don't know, we'll see. So anyway, when we start the timed block, we do what you would expect here. We go ahead and pass, I guess, all the information through to this macro here, right? So this one's going to call it directly, and then the external code can call this non-directly. I think that'll work. We'll find out. So this would do begin block underscore name, like that. Although in this case it needs to do something where it's going to pass like a bunch of these things through, such as whatever the actual counter value is, whatever the file name is, whatever the line number is, whatever the function name is, or I should say the block name in this case. And then I don't know about the hit count just yet. We'll see if that ends up being something that we still want. So I'm going to put the block name there, the line number, the file name. We'll get the debug record the exact same way we always get the debug record. We got the counter in it, so that's all fine. And we've got the record debug event, which is going to work off of the counter there. So I guess all we really need to do is pass the actual counter here. In fact, I'm sort of starting to see how this pulls together a little bit better. So when we do the record debug event, we've got the counter there. So there it is. We'll just pass it in. And then the name bit doesn't have to flow through to here. So it's really just going to be the counter, the file name, the line number, the block name. And that's all it should really need in order to work. Everything else looks like it should be pretty much okay. So if that's the way we do, let's see, if that's the way we do the block begin, then what we need to do now is go, okay, if that's how we're doing begin, whenever we call begin block, we need to be able to generate these things from it. And so what we want to do there is, first of all, we have to make something that records what the counter is. Right? And so what I was thinking is we could do something like say, oh, okay, it's going to be like counter underscore name. So whatever the name is, that's where we'll store what the counter value actually is. Does that make sense? And then what we can do is call begin block, because now we have this information. We can just say, okay, begin block with the counter that we've stored so that the end block can use it, right? I'm worried about this guy being able to use it, essentially. So we've got that. We know we can get the file name just from the compiler. We can get the line number from the compiler. And then the block name is just going to be whatever name we actually got passed. And there's our begin block, and that should just work, right? Then our end block will pick up the counter from here, so it will be able to do the record debug event that it actually needs to be able to do, right? And in order to do the end debug event, all it actually needs is that counter value. And so we know that it would be this counter value here would be the name of it. So, again, we just make a second one up here so that it can work in both cases. I suppose, actually, I don't really need both of them now that I think about it. Well, it doesn't matter. I'll make them both anyway. So we've got, both ones here, and this is just going to pass in whatever the counter is actually supposed to be. And so whatever the counter is in this case, it will go ahead and do the record debug event, like so, with whatever that counter is and the end block marker. So if you are to call it like this, then you get exactly what you would expect. If you are to call it down here, you pass sort of counter as like a special case to it. And then it can pass through all the stuff that came from the other macro, right? So it's really this is just a bunch of conduiting, right? It's just a bunch of conduiting. And really we should probably call this timed function, but that's kind of another situation. We can talk about that in a second. In fact, I'll just go ahead and call this block name, and I'll call this block name. and I will say that we are calling this timed block thing. This is going to be called timed function, so that way it can pass the function down through everything, right? And then we can just change that so that it makes sense, and that way it's not timed block, it's timed function, right? Okay, because then we could have another one where we give it a specific name, and that would be kind of nice as well, right? So anyway. All right, so you can sort of see what's going on here. This all hopefully makes reasonable sense. So this is going to call nblock underscore with, again, that counter that got stored in the previous macro, this guy up here. And so I think that should basically do what we want. We don't need the manual time block thing anymore. That's actually just handled for us here by that sort of name concatenation. So I think that whole thing sort of roughly checks out. We've got to now handle all of the chaos that I will have caused by making these changes. Certainly the block name does not exist in the debug events because what are you going to do? I changed that. So we need this to now be block name. There we go. And then when we come through here, timed block is always going to be timed function from now on. And so this guy should be something else. In fact, this guy we should just call timed block. And we could call this like, pixel fill or something like that, right? Yeah. I'm just going to call it pixel fill for now. I can't think of a reason not to call it that. So we're just going to call it that. All right. This should be a timed function. This should also be a timed function. This should be a timed block called pixel fill. Again. This should be a timed function. Timed function. Timed function. Timed function. Timed function still. Timed function. These are basically all going to be timed function except the odd case where we got a second one in there where we wanted to give it a name. Right? Okay. There are a lot of these. Okay. Let's take a look. Timed block identifier not found. That is true. Timed block should be timed function and timed function. There we go. Okay, pixel fill. Yeah, I should probably also define timed block. So if I do timed block like so, basically I'm just going to clone this. I could probably get away with actually making these macros call each other, but I don't really want to think about it too hard at the moment. So all I want to do here is say that this function right here is like block name, right? And in fact, I guess, well, now that I think about it, I could probably do this pretty easily. But yeah, so you just pass in the block name, right? And so you still get the same exact behavior. In fact, I think I'm gonna put this like this though. You still get the exact same behavior of the macros, so I think I can just consolidate these things trivially, right? So you pass a block name for timed block, and that will always have that block name coming in first. So that makes it really trivial to implement timed function in terms of these guys. I think that means all I'd have to do is say, okay, pass the function name first, and then I get the same thing. And then I don't need the rest of those, right? So now you can write timed function and timed block in terms of the same little weird macro cracking thing that we had to do to get the correct concatenation there. Okay, so timed function now just calls timed block in all cases. Everybody always calls timed block underneath. And so that can go back to the way that it was. So in the case where you pass this in here, the block name, I guess I need to turn it into a string, obviously. So we'll do that. And then these are going to be, again, timed function pretty much everywhere that we had timed blocks before are timed functions now. So there we go, and so on. Again, same thing. This is a timed block. this is a time block for the debug render group. I guess we'll just call it that. Okay. There's a time function. And function name, that's true. It should be block name. And it should be block name everywhere now. So I never want it to be function name anymore. So let's see, function name. Got rid of it there. And here it should be block name again. So now we are in better shape. Function name, block name, doot, 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 doot. Okay, so now we need to actually pass some stuff here for our time block. So this is the Win32 loop, I guess we could call it, maybe. I don't know, seems like a reasonable name. And then we've got executable refresh for our begin block. Okay, so now we got to go make those macros actually work properly, hopefully. Let's see here. So begin block. Name. That all looks good. It was not expecting a string as the final thing. Is that what I am to be told? What is the that actually looks like what I would have expected. Let's see, block name is there, pound name. So I'm not sure exactly what that's complaining about. Counter underscore name is the counter, and that's all good, it looks like. Record debug event, working off the counter. So what is it actually complaining about? Syntax error string in begin block executable refresh. So if we were to call begin block with executable refresh, we get counter underscore executable refresh equals counter. That seems fair. We'd have counter underscore executable refresh getting packed into there, the file, the line number, and the name stringized. So we come up to here to begin block. Again, we've got counter underscore name there, which means it would be replaced here. Thanks, Visual Studio, by the way, for not telling me any information about this whatsoever. That's always really helpful. So LLVM gives you like the macro expansion and stuff. It's really easy to debug stuff like this. For all the ways that Visual Studio's debugger is way better than the ones on Linux, the compiler on Linux is way better than the one on Windows. Okay, we grab the record out by adding the counter. I guess what I'm going to do is just do what I have to do here because the compiler gives me no choice. I'm just going to start pulling apart parts of these to see which ones it's complaining about, right? Okay, so that makes sense. So it looks like that there's nothing wrong with that. It doesn't mind that at all. So I'll kind of come out a little bit more here, move this down, right? To here. See how that goes. So syntax error string. Oh, it's just that. Okay, so file name, line number, and block name. So I just gotta, make some way of these things getting put in, so they don't name conflict with the members of the struct. That's just me misremembering when it decides to expand and when it doesn't. So that's easy enough. Fixed. So I think that should be it. Now, of course, this use of a temporary here is going to be a problem. So what we really want is to just block these, right? Put those in a block, so that way the record itself won't name conflict with anybody, and that should be fine. All right. So we don't pass frame end info anymore, and so now we're pretty much done with that stuff. There's just one problem. And that problem is that we don't actually have the global debug table when we're in here, right? And you can see that unresolved external. So all we really need to do to kind of finish up to get this, I think, working, is we need some way of the debug table itself actually sort of being able to write in when we load the DLL. We need some way of grabbing the global debug table from the system, right? We need to be able to say that global debug table points to something, right? And so I'm trying to think of what the best way to do that would be. I'm thinking that probably what we would want to do is make sure that when we load it, right, we need a pointer to the global debug table. So let's see here, the global debug table, 32 Handmade platform, like so. So when we did this, we have the global debug table, and we need a way of pointing to that, right? We need a way of accessing that. I guess the only thing that's kind of nasty about this is the way that I did it here, it's not actually a pointer. That's kind of a problem, because there's no real way for me to have that work that I can think of. Yeah, I can't really think of any way to make that work if it's not a pointer. If it's a pointer, it works fine, because then I can just point that pointer at anything that I need to point to, right? And that's not really a problem. So I feel like this kind of needs to be that, which is unfortunate because it means there's some indirection to the way that we're writing things, instead of it just being a constant location. But, you know, well, we'll see how that goes. So if I was to do that, I'm wondering if I can get away with it. Let's find out. Global debug table dot global debug table arrow. So there we go. Let's go ahead and run that. So the global debug table now is going to be like debug table, global debug table, right? And then we've got a pointer to the debug table, which is just this, right? And this guy is actually a static, right? This guy is actually a global variable. And so he doesn't actually export, but this guy does actually export to the other stuff. Okay, so I think that's pretty much all we would need to do to get the mainline code working. However, now we still need a way of getting this to work, you know, so that the external code, the platform layer, can get a hold of it, right? So let's go ahead and see if we can just finish porting this up here. There we go. Events. And done. Okay. So obviously, if I just want it to compile, right, and I don't want it to actually work, like I don't want it to actually, I don't care if I actually get the information, then it's not so hard, because then I can just say we've got a debug table. That's the global debug table. Global debug table, and I've got a pointer to it. Global debug table, right? And I just define one in the platform layer, and now these two sections, the thing on either side of the DLL, are actually, you know, writing to two totally separate places in memory. So when I run this, right, well, when I run this, apparently I will just crash, which is also often, which is fabulous. What is the problem here? Why is my pointer not initialized? Global debug memory. It is undefined. How is it undefined, people? What's going on? What is going on? Let me make sure I didn't do something stupid. Well, I obviously did something stupid. So that's an incorrect statement. What I mean to say is, let me make sure I didn't do something obviously stupid. I feel like this should have been initialized. Is it not being initialized for some? No, I feel like that should be. I feel like once it gets loaded, that should be correct. But it's obviously not, so I'm pretty interested to know why it's not. It's the very first time through. I don't understand why I can't access it. Am I typing it in wrong? Global debug table. Right? Global debug table. Oh, I guess I was typing it incorrectly. So that actually looks okay. So maybe, okay, yeah, sorry. Don't want you to do that, I suppose. So I guess maybe it's just actually a problem with the way I implemented timed function. Maybe I'm just being, I was blaming the wrong thing. It could be that I just made a mistake in here somewhere. So when it does timed block and it actually starts this up, maybe I was doing something stupid. Ah, that's the problem. I just didn't initialize counter. That was it. So that's fine. All right, so now we're back to what I was trying to talk about before. So if I run this, it'll work just fine, but the problem is now the platform layer is writing into a different debug memory, right? It's writing into a completely different area of memory than where we actually want it to write to. Because I just declared there's one on either side of that DLL boundary now, so the ones that the Win32 platform layer, everything it writes to is in totally separate memory from the other one. So what I need to do now is I just need to hook them up, right? So what I need to do is say, okay, on the platform layer side, right, where we've got this global debug table, on that side, what I can do is if I can just get the debug table out of the sort of the DLL here, right? If I can, when I actually do this, right? So when I load the DLL, when I do Win32 load game code, when I load the game code, I can just switch what debug table I'm writing into. That would be fine. So when I load the game code, what I can do is introduce a function there, which is like, hey, I need you to give me back that debug table. And so I think the way that I'm going to do that, the way that I think that I would prefer, is at the end, after it does its like first collation pass or something, then I will go ahead and get it from here. So what I'll do is I'll say global debug debug table, my pointer, my global table. I'm just going to override it with whatever you tell me to do, right? Something like that. Does that make sense what I just said? I feel like it does. Except I don't really know. To be completely honest with you, it would seem a lot more sane if what actually happened was it lived in the platform layer side, and then the executable wrote into that. There's reasons why that's not so good, because that does mean that also the strings in it don't map correctly, because when the DLL gets unloaded, all of the strings that were in there are going to be invalid, and that would be annoying, right? So I don't know. I'm going to do this for now. We'll see. So what I'm going to do here is I'm just going to say, okay, whenever we're going to unload this thing, when we do Win32 load game code or something, we're just going to turn it off. So when we do unload game code, we're going to turn off that global debug table. We're going to point it back at our global debug table. Right? And then when we get it loaded, we'll just reset it. That seems fair. Yeah, that seems fair. Now we have a problem, which is that we need to reset this, but that's okay. We can always reset it over and over again, so it doesn't overflow is basically what I'm saying. So what we can do here is anytime we get to the end of this loops, we can always do our global debug table, the sort of the stub one that we have, that we use anytime that we don't have anything that's loaded. We can just go ahead and say, oh, okay, you know, whatever that one's event index, array index thing is, we'll just clear it back to 0. That way we know that it's never going to overflow because we clear it at the end of every frame anyway, right? So that seems pretty straightforward to me. I feel like that'll work. There's probably a better way to do that if I thought about it a little longer, but I'm not sure I super care at the moment, but that's something that's probably worth kind of drilling down into a little bit more. If you really wanted to make like a sweet system, you'd probably want to figure out a way to get that sharing to be better. Like I'm 99% sure I could do it. I just don't want to spend, 30 minutes or an hour just, kind of playing with that and going, what's the exact right way to do that? So yeah, I think that should do it. And then we need to just, when we have debug frame end here, I just need to return the global debug table from there. And now they should be writing into the same place in theory, at least in some kind of a theory, right? Why is it a void function still? Where is my definition? Define. where is debug frame end? There it is. Debug table. Okay. Struct debug table. And yeah. So I feel like now we're getting a little closer here to success, although we're not there yet. I don't see our platform stuff showing up in here yet, right? So we have not succeeded yet. So let's go ahead and take a look at what's happening here. So let's go here and let's take a stop right there. So the global debug table, right, is pointing at, well, it looks like it's pointing at the right thing. Is it? Let's see. Yeah, it's definitely pointing at the right table. So we grabbed it. So that's good. And then we're clearing the one that we're not using. So that's kind of unimportant, right? So here's our Win32 loop. Oh, you know what? It's probably just fine. We just never actually are printing any of these guys out, right? So we just need to finish what we were doing in Handmade Debug to actually print them out, right? Because if I'm not mistaken, this part here doesn't ever actually grab the ones from the platform layer, right? The debug records platform count is always set to 0, which is not what we want. So let's see. What would we have to do to make this happen? We come through the counter counts, we clear them, we do this stuff here, counter states, and then we set the snapshots up. So I think all we'd really have to do is now finish the part where we figure out what the count actually is, right? And in order to do that, what I think we should do is in the debug table itself, I feel like the debug table should have that information, right? Like you'll notice we didn't actually, we don't actually have that. We never actually put that in there because they were constants and such. So what I'd like to do is just say that the debug table itself, this guy, I'd like this, you know, I don't like the fact that that's not aligned. We're going to move that forwards. In here, I'd like to have the ability to get the counts out, right? So something here where we do this, I'd like to do like record count, like this, where we have the record count per translation unit. And that way, that'll always sort of be kept up to date by other people who are, you know, who write into it or something like that. And so the way that that would happen is we'd get rid of this debug platform count thing here, and instead what we do is we just go, you know, the total count, total record count is just going to be the sum of all of the translation units, translation unit index, or I'll just call this unit index, right? So unit index is going to be looping over all of these. It's going to take that debug table, so global debug table, record count for whatever unit we're talking about, and it will sum that, like so. So then we just know that the debug state counter count is just equal to however many records we have total. We then come through and we clear them all, which seems fine. We then come through and we initialize these, and so that the way that we would initialize those actually, in fact, we could even do that up here, right? So what we could say is, all right, there's an array of counters. The array of counters is however many translations units there are, like so. We won't initialize any of them. We start off with the pointer that we are talking about is going to be counter states, right? So that's basically debug counter state, like current counter or something, like that. So we define that, and then as we go through here, when we want to say which one of these, you know, where the counters start in this flat array that we've created, we just say that whatever translation unit we're on, that equals the current counter. Oops, current counter. And then we just add current counter, we add to it, we advance it by however many records there were. And now we just have that working, and we don't have to worry anymore. And and now we're generic in the number of translation units as well. There's no hard-coded stuff in there, so you can just kind of arbitrarily have however many translation units there are. So as we come in here, what I'd like to do is I'd like to go ahead as well and make sure that we just overwrite these every time just to make sure that they're current. So we'll have the record count for the translation units that we actually know about. And I'd have to think if there's some way to make this part automatic. Because it'd be nice to have the whole thing so that we don't have to care about that. But I don't know that that's actually a realistic thing to think about, right? So you can see right here we've got these guys. Okay, so if I come in here and say we've got the optimized ones, the optimized one is the 0th translation unit, if I'm not mistaken. Build up that. No, it's the 1st translation unit, right? Yeah, that's what I did. I said the wrong thing. And then the main count is this one, and so that gets written in there. And then we just have to count on the platform layer to actually write in its actual correct piece of information, right? So in order to do that, in Win32 Handmade, what it would need to do is before calling into here, it would need to say, or I should say possibly after calling into there, it just goes, okay, when we get back the global debug table, we'll set the record count for our translation unit, and off we go, right? So the record count for our translation unit is going to be whatever our total counter count is. So I guess it's that, right? Although it's kind of a little annoying because that means you can't do it. Yeah, I should put it to do here. I have to say that it seems like maybe the counter thing is a little more trouble than it's worth, right? Because we do have more than one translation unit, it ends up not being as clean as I would like. You have to do this extra stuff for the multi-translation units. If we didn't do the dynamic code loading, it would have, could have the sort of like windowed optimization where we just literally only had one translation unit, it would have been a lot nicer. But it's forcing us to do a bunch of things here, and I don't super love that. It's okay. I mean, every time you find a new technique, you don't really know how effective it's going to be, and there's a bunch of different things that maybe we need to think about more carefully about it. But it's worth noting that it's annoying me how many little fiddly things there are like that, which maybe suggests that we don't really want to do it that way, at the end. Something like that. But anyway, I think that should work now, I believe. All right. So now if we take a look at what's going on here, in theory, we should be able to find, we should be able to sort of see all of our Win32 stuff. And you can see now that we've got like our Win32 loop is here, our executable refresh is here, input processing is here, our game update is here, audio update, and so on. Right? So we've got these things. We don't really know. We haven't done much testing of this yet, so we don't know how well this is working. But we're basically, we're sort of narrowing in on it actually, working particularly well. It would appear. Unfortunately, we're starting to get too many things in here, but that's okay. That's exactly why I did this whole round of work, anyways, because now we can start to make something that's going to let us see things in a more intelligent way, right? So this is a weird number for the Win32 loop. Oh, I suppose that's because it's never going to be closed, right? That loop won't be closed. And so that's another thing that we're probably going to want to play around with. Basically, when we actually run those numbers, that loop will not have closed because that loop actually closes out here. So it will not actually have closed in that time period, if that makes sense. All right. So the last thing I would like to do, and that took longer than I was hoping, right? We had more work to do than I would have hoped. So I don't know that we're going to get to some other things I would have liked to have done, given the short amount of time that we have still left. But I can do a couple of the things that I wanted. So the first one I wanted to do is have some kind of a notion of like a frame latch so that we can tell in the debug event stream, so that we can kind of tell where the frame boundaries actually occur, right? So just something that's like frame boundary. You know, it's like this was the end of it or something, right? Although I guess now that I think about it, maybe we don't even need that, because we kind of have that. If we just make sure everything is always inside one giant block, maybe we just kind of have that. I don't know. I guess I won't do that yet. Let's just continue down the path and see where we go without actually doing that first. Yeah, let's just see what happens, I suppose. Okay, so I guess what I'll say is, yeah, you know, the only thing is you'd want to, well, okay. I'm having like an internal dialogue here, and I feel like I'm going to want a way, right, to mark something as like the frame boundary. And because the reason I say that is because we have, it's sort of extra information. It's a thing that says this is the natural unit I want to like view things by. You know what I mean? So I feel like what we actually want there is a special marker, right? That says that this is how you should chop up time when you're visualizing it. Everything else is a block, but I am actually special. I'm the special point in time that says this is a logical frame that like is what I want you to display in terms of. You know, it has no other meaning besides that, but it's what I want to see. You know, and so instead of having this be time block 132 loop, you know, instead it's something like this is the frame marker or something, right? Something like that. And so what the frame marker is, it would be a very special thing, a call to record debug event that would be like, you know, particular, very particular. So when you call this frame marker function, what you actually would get is record debug in event for like a special record index or something like this. You know, I guess it doesn't have to be special. It can still be counter, I suppose. But you know, whatever that one is, the event type of it is not the standard event type, right? Instead of the normal event type, it's actually going to be some kind of a special marker that we have here. So it'll be like debug event, you know, frame marker, like so. And so that way we can just insert that in there specifically. And when that happens, we could also, if we wanted to, we can fill out the rest of this stuff, right? You know, we can do something like this if we want to. So maybe I just will. I'll say int counter equals counter. I'll say record debug event frame marker. So we got that. And then I'll do this part here as well. So I'll say, okay, debug record. Oh, and well, okay, I'm going to keep going. There's another thing that I could do here that was kind of interesting. But anyway, we'll get the debug record out, and then we'll just write in here, I guess, the standard stuff, like file, line, and then the block name. Yeah, I guess the block name is just going to be frame marker or something like that, right? So that's what I want. That's what I want to have happen. I need to finish my backslashing there. And so now I suspect, okay, good. Yeah, I was going to say, I suspect we'll have to change a couple things in the printout routine just to ignore those events for now, since I'm not actually using them for anything. So that assertion for end block, that actually needs to be in here if event type equals end block, then do this. Otherwise, don't do anything, and that's fine. Okay. So now we're back to everything. I think everything should be roughly correct now as well. Like, I don't think we should have any of those like forced open block nonsense things happening. So that's good. And that all looks reasonable to me. Okay. So the next step in this process is we need to start looking at the frame. We want to start being able to look at this debug log potentially as just one giant log in some sense. And so I'm wondering, right, like let me just give you a little drawing here of what I'm thinking. I'll go ahead and pop over to the Blackboard. So there's day 183. So this is the debug log. So what I'm thinking, right, is what's this debug log going to look like? You know, it's going to have a marker. Here's the frame marker. It's going to have a bunch of like begin-end pairs, you know, that look like whatever they look like, mostly hierarchical, probably, you know, although they're not required to be, something like this. Then there's going to be another frame marker, and they're going to keep going. Now, some of them might span that frame boundary, right? Because there's things that are happening like asynchronous operations, which might span the frame boundary. So what we want to be able to do is get all this stuff into like a rolling log, and so that we can kind of view that even with stuff that crosses the frame boundary. But we also need to be able to make it so that when we run out of room, you know, we have a way of clearing it eventually, because otherwise we'll just keep writing log information if we just kept writing to the same buffer. So we have that like ping pong scheme going now. But I think what we probably want to do is we probably want to make it so that we actually let it write for a lot more than a frame. You know what I mean? So that we get like many frames of data, and then we just we like move the sort of the place where it's safe to read and safe to write almost more like a circular buffer, so that we can kind of like keep using data from you know, as it goes. So I feel like in order to do that, I mean, we just need a lot of memory for it. It's not like a huge deal, right? We just need a lot of memory for it if we want to store all that information, which does sort of pose a problem for the fact that those things are statics. We would rather be able to have that be memory passed in that we virtual out or something like that, which again does suggest that maybe the part that gets passed sort of forwards instead of passing backwards like we're doing here might have been a better way to go, just at least in terms of where the memory comes from. It's hard to say, right? But anyway, so when we come through here, and that's the end, I guess we're at where we got like maybe a minute before Q&A, so I'll have to wrap up. But when we come in here, we swap out which buffer that we're doing. Now, we could do something like taking the debug info, and I guess we could just copy it out to some memory and string them together as we go or something like this. I don't know that that makes any sense, because then we're wasting a bunch of time copying when we could have just left it in the place where it was. On the other hand, I do fear that if we, you know, jack the size up too much of the actual debug table, that we're going to end up with some kind of a nasty situation because we have too much data in the static section. I don't know if that's still a problem anymore, or too much, not data in the static section, but I mean asking the operating system to allocate too much for the executable. So like, for example, if I was in here and we said events, and instead of 2, we were to say that we want, you know, like a ton of these, like however many frames we want for our snapshots or something, right? So this thing is like huge. Yeah, that's what I thought. So you can't exceed, right? You can't exceed a 4 GB array or something like that, right? So I don't know. I don't know if something like that is really pushing the limit. You know, how bad that's going to be. Looks like it's okay, I suppose, for that many. So maybe that's a reasonable thing to do. And so then we would have effectively 63 frames of look back. So it's writing into the 64th frame. We have 63 frames where we could look at those events over time and, you know, be able to kind of go through them like that. I don't know how necessary that is, but we would at least have it. And so if we wanted to do that, right, it's not too tricky. all that would be, it's not really very different from what we're doing here. All that would require is when we come through here and we do this like current event array index not equal cut, we wouldn't do that. We would just do current event array index. We'd do like a plus plus of it, right? So we'd say like, you know, go to the next one. And then we would just say if, if it is greater than or equal to the array count that's in the debug array, it gets reset to 0. Right? So that's the debug global debug table, events. And so now I believe that is just keeping that rolling buffer. So we can actually now look across frames because we just have the events for everything. And it also means we don't really need the snapshot stuff anymore, right? We don't really need to worry about that anymore because we could actually recompute that on the fly if we wanted to. So the snapshots are really not necessary at all anymore. So yeah. So I feel like that's probably the right way to go then. To just take a huge amount of data, to just take a huge footprint there. Because again, this is not something we ever have to worry about running on an end user's machine. It's only for debugging purposes. So if we want to, we can just say, all right, we'll take a huge amount of memory. We'll just slap those things in there as we write them. And, you know, it's not as good as if we just did a circular buffer. So it kind of feels more like we probably want to write to a circular buffer there. But I don't really want people to have to do the circular buffer check is the problem. So I don't know. We'll see. We'll leave it like that for now, but we'll see. Because there's no real downside to doing it this way. You always want to have a ton of memory in your dev machine anyway for doing stuff like this. So you can just do whatever the most, you know, expedient thing is that allows you to actually capture the information that you want. You don't want to have to constantly be thinking about is it frugal on memory when you're talking about code that's meant for instrumentation. So that might be fine. We'll see. But now that we have that, what that means is I can go ahead and say, okay, let me look back across the previous however many frames we want, and I can find the frame boundaries. And now it doesn't matter when in particular you updated the debug. There can be things that straddle those markers, and we'll be able to look at all of that data correctly, and there won't be any edge cases where we can't see what happened because it's like an event that spans 2 frames or more. And that's the thing that I was really worried about, because I want to be able to see those sort of events that exist outside of a single frame in terms of encapsulating. All right, so I think we're good. And I think we're done now with that. So we should be able to work on viewing tomorrow, because there's nothing that seems like it's all working, unless there's something that we're missing there. So we can do Q&A. Hotspur, are you going to start the hardware renderer before starting the game logic, or are you going to wait till the software doesn't cut it, or are you waiting for Vulkan? Yeah, I don't know that I'll ever do the hardware renderer if we don't need one, right? So the hardware renderer will happen when we decide that we, you know, want to do too much stuff on the screen, right? And so we need hardware. So I suspect I won't do it. I mean, I might have the game essentially be done on the software renderer, and then only do the hardware renderer as like a thing that we do up as an additional thing. But you know, we may be forced into doing the hardware renderer earlier if we want to do some things and find that we can't do it because the software rendering is not fast enough, right? Did you just use the blue line sector and green cursor to make it easier to follow on stream? Yes. Or is that how you normally like it? I feel like it would get fatiguing to the eyes. Yeah, I don't normally do the blue line. The cursor may normally be green, though. I don't remember what my cursor... I think my cursor may normally be green, but the blue line is strictly for the stream. Elvin, when do you think it is a good idea to use somebody else's library system instead of implementing your own? Well, it's if you think that it's as good as what you would have implemented, right? Or similar quality, right? I mean, that's why I use the STB libraries, is because, you know, across all the axes, Sean's code is going to be like my code, right? In my opinion, I don't think of it as having to use this crappy thing that people who I don't trust wrote, which is how I feel about most libraries. I feel like it's, like Sean wrote it. I know it's going to be good. I know that it's going to be like well, you know, it'll integrate well. That the API is sane, right? And so when you have that kind of a high quality library like that, it's a very easy decision to go, oh, I can just use this, and I'm not worried about what's going to happen, right? There's very few libraries that I would say that about, but that's the thing. Another way might say, you know, if the person who wrote the library was someone that you'd want on your team, right? Then that's a good sign that you probably would be happy using their library. And like most libraries out there are, you know, written by people who I wouldn't want on my team, and I don't want to use their library, just like I don't want to hire them, right? But a lot of that takes experience. It takes experience to know before you actually use something whether it's going to cause you significant problems or not. So I don't pretend that that's an easy judgment call to make. It's something that I feel comfortable making at this point because I know my development process. I know what I am and am not okay with in terms of using people's libraries, because I've had a lot of experience with that. And I realize that it's harder for people who haven't had experience because they don't know what they like. They don't know what will cost them stuff down the line. You know, until you've built up that experience, you don't necessarily know what you do and do not consider appropriate, or what you do or do not think will cause you problems. I gotta go early today. I gotta go in like 5 minutes, so I'm just gonna quickly scan to see what we've got here. Huber Caleb, missed the first half of the stream. Are you saving the past 60 frames into a buffer? Yeah, I'm saving like all the debug events now. And because I think I want to have, I'm just thinking of how we want to view them, and I'm pretty excited about that. And so I've been trying to make sure that I've been trying to iron out enough things in the system so that we can really get a view of everything instead of only like things that happen to like be nicely encapsulated inside a frame and stuff. Elvin, let's see. If a miracle happens, C++ starts doing things right and addresses the issues in the implementation of most of their features, would you use their features like templates or stick to metaprogramming? I don't think it's probably a useful question to answer. I mean, I think C++ is so bad at this point, I don't think they're going to pull it out. In the debug display, are we going to see something like Brendan Gregg's flame graphs? I don't know. I have not ever really looked at those. Probably not. What I want to do is more of a like hierarchical zone drill down, if that makes sense. Although maybe that's what a flame graph is, since I haven't seen one, I don't know. Insofar as I think a lot of people would like to see how to write a hardware renderer, myself included. Yeah, I mean, a lot of people would like to see a lot of things, but I have to keep the amount of stuff that we cover to a certain thing, right? A lot of people would probably like to see how to write a 3D engine as well, but I'm not going to do it, right? Because I have to keep it scoped to something that I can reasonably accomplish in a reasonable amount of time. So in general, I will cover the things that I absolutely know that I want to cover, which is basically how to write a complete 2D game from scratch. But I'm not going to add anything on that I don't think is necessary for showing that complete process, right? And so hardware rendering in particular is not really that interesting to me in a lot of ways because it's super transient. I don't even think it will exist in 15 years. I don't think there will be such a thing as a hardware renderer. So it's a very like temporary thing, whereas everything else that we've covered I think is sort of knowledge that'll be useful for a very long time. The only problem with it is that, it's tied to a particular language, but if you can factor out a fair bit of that, I think it's more generally applicable to just how to program. And that's pretty important to me. And so the hardware renderer part, I feel like, is just kind of, if I didn't think that we might need it just in terms of the game being able to run well, because modern machines have a lot of their horsepower in the GPU, right? If I didn't think we would need it because of that, I just would have said we were never going to do a hardware renderer right from the beginning. But I assume we will probably hit a wall at some point where we just have too much stuff on the screen and software rendering is not optimized enough or whatever, and then we'll have to do one. Captain Craft, getting good at running game engines, write lots of them or work on a few larger ones and continue improving them. I would say you don't have to write lots of things in the whole scope. What you want to do is just make sure that you iterate on the pieces, though, or on the architecture. Like, you want to always reassess and question your initial designs especially as you learn more as a programmer. So, you could work on one engine for 10 years or 20 years. And you can learn a ton and do a lot of really great work there, as long as what you're doing is constantly like changing the way things are done and improving them, right? If you just let it calcify after the first year and everything is just kind of endlessly adding junk on top of it, and you never like revisit and refine and change and improve, then that wouldn't be so good. And then I'd say, yeah, you probably want to do multiple game engines, because that's, the way you would learn. But as long as you're willing to never say something is set in stone, you can just have one engine that you keep working on and it keeps getting better. And I think that's a good way to go too, because that way, you don't feel like you're starting from square one all the time. You can always go like, what's the section I want to like rip up and replace of my engine today? And I'm going to start working on that for a few weeks, few months, whatever it is. And then when that's done, I'll say, what's the other cross-cutting thing? And you keep letting it be pliable. And I think that would be a totally fine way to go. All right, I am going to close it down early today because I gotta go. I got to go. Okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, it comes with the pre-order of the game, so if you want to, you can head over to handmadehero.org and pre-order the game on Handmade Hero. You can pre-order Handmade Hero using the little pre-order button, and then you can download the source code every night. After I'm done with it, you can just go grab it. There's also a forum site if you want to go ask questions or take a look at the annotated episode guide the community members have made. It's pretty cool and getting very complete as well, thanks to some dedicated folks. And the Patreon page we have is for supporting the video series. If you just want to support the video series separate from the game or separate from anything else, that's a place to pledge to do it, and it's always very much appreciated. And finally, we have a tweet bot that tweets the schedule at you, and so if you want to catch the stream live, that is the place to go for that. Speaking of live, the last stream tomorrow, Friday, 5 p.m. Pacific Daylight Time before the weekend break. We'll see you all back here, hopefully, and then I'll finally get to do some of my Debug Viz stuff, since I think we've now finished everything. It took a little more time today than I was hoping. I was hoping to do some of it today, but we didn't get a chance to do that. So tomorrow we'll start down that path, and I think that'll continue for a few days, because I think we want to basically spend a bunch of time now making it so that we can kind of explore our debug information in a nice kind of handy way. And then after that, we'll start looking at maybe how to augment what we have right now, which is perf stuff, with some more different kinds of information. Like it'd be nice to get some memory information in there. It'd be nice to get some diagramming in there. And so we'll see about like just kind of augmenting what we're already doing with a little bit more. So that's about it. Hopefully I'll see you back here for that. Until then, have fun programming, everyone, and I'll see you guys out on the internet. Take it easy.